Now for the absolute value inequality, the two cases, the less than and the greater than, are different, not like the quadratic inequality and the rational inequality where they were the same. Here they are different. So let's look at both cases. The first case, let's look at the less than. Remember the meaning of the absolute value. We just said the absolute value means the distance from zero. So now if I go back to my scratch paper and talk about what happens when the absolute value of x is less than, this time, 3 units. What do I mean? I'm saying that the distance from 0 is less than 3 units. So x could be anywhere between here to here, because any place here, 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 all this is the distance is less than 3 units away from 0. So that means this is gonna be equivalent to saying the three-way inequality, x is greater than -3 and less than 3, right? Let's look at the greater than, so we can talk about all these situations, the two situations at one time. So now what do we mean by absolute value of x is greater than 3? So now from the 0, I'm saying that the distance from 0 is more than 3 units. So x cannot be here or here. It has to be more than 3 units. So anywhere from here to here. And listen to the next word I'm saying, or anywhere between -infinity to 3. So a point cannot be here and here at the same time. So we cannot use the word and. Whereas in the less than, a point here is said to be greater than -3 and less than 3 at the same time. So that's a three-way inequality. But a point here is separate than a point here. So this here is x is less than, all this time I forgot the negative. X is less than -3, or in this interval where x is greater than 3. So now the equivalent to this is this statement or this statement. So we cannot put these two as a three-way inequality. So now let's look at it here. So here's the first case. Absolute value of x is less than k. Equivalent form is the three-way inequality. X is greater than -k and less than k, and that's the graph, and the interval notation is -k to k. Whereas the absolute value of x is greater than k is equivalent to two separate inequalities. Either x is less than -k or x is greater than k. And the interval notation is -infinity to -k union k to infinity. So let's do examples. So I gave two examples here that were done for you, straightforward, nice. Let me show you a nice way to think about how to rewrite the equivalent statement. Just rewrite what's inside without the absolute value sign, make it less than or equal to 5. All you need to do is add greater than. So you switch the sign from less than to greater than, and switch the sign of the right hand side to negative. So switching and switching, then you get three-way inequality we know how to solve. Same thing here. Let's see what we're gonna do. Again, if I take this one out, see, it's the same thing exactly without the absolute value, and all we do is add the following. Instead of less than, greater than, and instead of 10, -10, and solve. So let's do the next two examples. In these examples, I have something on the left hand side with the absolute value. Well, all the rules that we talked about are only for absolute value on the left hand side. We cannot have anything with it. So the first step has to be to first add 2 to both sides. So I'm going to get the absolute value of 5x plus 2 is less than at 2, 5. Now how are we going to rewrite it? Again, look at this. As is, without the absolute value sign, and we're going to do the following. We're going to switch the sign from less than to greater than, and from 5 to negative 5. Now I have a three-way inequality. We're going to solve it by subtracting 2 from all sides, and now dividing by 5 all sides. And now the interval notation, there's no equal sign, so it is parentheses, negative 7/5 to 3/5. And same thing with the graph, negative 7/5, 3/5, and everything here in between. Okay, let's look at this one. Okay, same thing. First we need to subtract the 3, and then we're going to rewrite it 5x plus 7 less than 3. So I rewrote it the exact same way and just add greater than negative 3. Subtract 7 from all sides. So 3 minus 7 is a negative 4. Subtract 7 from both sides, and then divide by 5. So negative 10 divided by 5 is negative 2, and negative 4/5. Okay, so now what do we have? Well, let's see. We have from negative 2 to negative 4/5, open on both sides. The same thing for the graph. Okay, let's look at some more example. Now the greater than, the difference, let me show you again. The equivalent statement for absolute value of x is greater than k is two separate inequalities. X is greater than k, or x is less than negative k. Okay, so let's do this first one. So I see that I have an absolute value sign and a greater than. So I'm going to have two inequalities. One of them looks exactly the same without the absolute value sign, or the 2x plus 1 is less than negative 7. Again, switch the sign, switch the sign. Now we'll solve these two individually. So subtract 1 from both sides and divide by 2. Same thing here, subtract 1, so you're going to get negative 8. Divide by 2 is negative 4. So two inequality, x is greater than 3 and or x is less than negative 4. So for the graph, put it in the order of the number line. So the negative 4 comes first here, and then the 3. And look at that, x is greater than 3, so it's this way. X is less than negative 4, so it's this way. And the interval notation will be negative infinity to negative 4, u 3 to infinity. Okay, let's do this one. First, we need to subtract the 6. So I have 5 minus 8x is greater than or equal. Subtract 6, you get 8. Okay, now let us continue solving. So it is a greater than or equal. Two inequalities. One of them is 5 minus 8x is greater than or equal to 8, as is. The other one is 5 minus 8x less than or equal to negative 8. Let's solve them individually. Subtract 5, negative 8x greater than or equal to 3. Now we're going to have to divide by negative 8. So what do we do when we divide by a negative? We switch the sign. So don't forget that. And here subtract the 5. So negative 8 and negative 5 is negative 13. Divide by a negative 8. That will make the sign switch to greater than or equal, and negative divided by negative is positive. Nothing can be simplified. So the interval notation is less than or equal. So this is negative infinity to negative 1/3 union 13 over 8 to infinity. And the graph, I have a negative on this side, the positive on this side, and then it's greater than or equal. So good thing I just noticed, of course, or equal, so it has to be bracket. Probably you noticed while I was doing it. So we have to include the point, and the interval notation is going to be that. Okay, so I'm going to leave these two for you to solve. Let me see. No, actually, no, I did those for you. Sorry, let's do this. Special cases, I would like to do that with you. So let's see, that's a greater than or equal. So 2 minus 5x is greater than or equal to negative 4. I don't want to solve it actually. The special case, I wanted to talk about it. Or 2 minus 5x is less than or equal to positive 4. But let's forget this in a minute. You are asked to find values of x such that this absolute value is greater than or equal to negative 4. Well, what do we know about the absolute value again? That it's a distance and it's always positive. So does it matter what x is? Absolutely not. No matter what value you put the x, you're going to get absolute value, which is a positive number. That's going to be always greater than or equal to negative 4. So the actual solution is negative, all real numbers, negative infinity to infinity, which is the whole number line. So that's a special case. How about this one? The absolute value of 4x minus 7 is less than negative 3. Less than negative 3 is a negative number. Does it matter what x is? Absolutely not, because no matter what, you're going to get something here positive, and the positive is never going to be less than negative 3. So there is no solution. So be careful with these two cases.